All right. Hi, everybody. Wanted to thank everybody for joining this presentation. It's going to be a really fun and interesting presentation. Jaime Martinez, the 3D application specialist for Mimaki USA, is going to be going through some of the tools and techniques that he uses in order to work with 3D textures for our full color 3D printing machines and printing processes. So before I turn it over to Jaime, just a couple little housekeeping rules. We're going to have everybody muted. If you would, please use the questions and answers chat window in order to put in questions. And as we get to the end of the session, Jaime will be answering questions live. The presentation itself is pre-recorded so that Jaime can make sure to get through everything that he wanted to get to and make sure that we stay within our time window. But having said that, I'm going to bring up the agenda and then I'll turn it over to Jaime. All right, Jaime, it's all you.
Okay. Hey guys, thanks for attending the Mimaki Innovation Days. Well, I have a really small workflow to show you, and so we're gonna cover 4 steps to develop a small part. It's a really simple texturing tutorial for all the people, so people can follow these. It's all the same concepts, and you can apply this in a different software platform. It doesn't have to be specifically for Blender or Adobe Substance. There is also other alternatives to create the texturing part and also to create the UV maps. So yeah, I'm gonna show you just a small video, and then we're gonna make a quick recap on it. So let's go with it.
Hi, this is Jaime Martinez from Mimaki USA. Welcome to File Preparation for Texture-Based Full-Color 3D Printing. In this presentation, we will modify a basic mesh and turn it into a high-detail full-color 3D print. The purpose is to encourage designers to take advantage of physical-based rendering texture workflows. Texturing can help to manage complex color and add physical details through displacement maps. All of this can be achieved by working in a non-destructive fashion and using the computer resources efficiently. I will be using Blender for Mesh Edition since we can visualize material nodes and UV maps in the same viewport screen. Texturing will be made with Adobe Substance Painter. This is a basic tutorial, so you can apply the concept of this workflow in other applications. So let's get started. I divided this presentation in 4 segments. First, on setting the purpose of the 3D print. Second, UV unwrapping the mesh. Third, a talk on texture maps for color and detail. And fourth, file optimization before printing. The scale of the object will impact the printing speed, level of detail, part quantity, and part tolerances if it's an assembly. I will scale this object to 130 mm tall, which is close to 5 inches. Notice the size change under the scale and dimensions. On a side note, Zbrush users can take advantage of the Scale Master plugin to resize their objects. If necessary, make sure to update the scale factor because it can affect editing and future transformations. Some objects will require to be printed in separate parts to maximize the print bed size, cutting cost, and reduce print time. Assemblies can also optimize weight or make the final print easy for packing and shipping purposes. When developing a part, keep in mind the tolerance and clearance to avoid fitting problems. Always test print the fittings to find the limits of your printer. In this way, you can avoid problems and print with efficiency. Now we move to unwrapping the mesh. Unwrapping is the process of creating a flat version of the 3D objects to project images for color and visual enhancements for rendering. Think about it as flattening a cardboard box or an origami figure. The idea is to find key edges and surfaces to create seams. Unwrapping can be simple or challenging depending on the geometry of the 3D mesh. The surfaces inside of a UV layout are called islands and can be moved, scaled, and rotated without affecting the 3D version of the mesh. To illustrate better, here are some basic unwrapped 3D objects. For the cube, I scatter all the main faces in the UV layout as islands. Selecting a face in the UV layout will highlight in the 3D viewport. If we move to the sphere, all the faces have been distributed to fill the UV layout space. There are several seams at the top and bottom to allow the mesh to unwrap in a square proportion. Image projections are easier when working with symmetry. On the cylinder, surfaces are evenly distributed and it's easy to identify each one of them. For the torus, one of the seams is located at the inside center loop of the surface and the other one in one of the vertical loops. In this example, the unwrapped version is using all the UV space, but you can select some of the parts of the geometry and create custom UV projections. Also, the software design tool will possess an array of options to unwrap a given surface. When designing, make sure to unwrap the 3D object in a way that is easy to identify the surfaces and manage the projections. Back to the design, a UV layout was created for the head with 4 islands. You can see them selected in both the 3D and UV viewports. The body has been divided in 6 islands, with seams cut at the center of the bigger components and at the base of the feet. The base is divided in 2 islands due to its surface simplicity. Once the UV layouts are done, it's time to assign materials and proceed with texturing. A 3D material contains parameters that can be quickly edited and linked to the 3D object. Physical-based rendering textures rely on nodes to assign those materials. In the colored mesh, there are 3 assigned materials with different parameters affecting their appearance on screen. To start assigning materials, the first step is to select a 3D object and add a new material ID. In this case, I will name this Head New. The basic node will be created and now I can assign a solid color and play with the parameters to change the appearance. For complex color, I can link an image previously created to the base color node. Notice how the solid color is replaced by the wooden texture. An object can have 2 or more materials assigned to its geometry. To add a second material, I will go to Edit mode, select a key surface like an UV island, and create a new material slot. I will assign the new material ID, clearing the wood material from the surface. Then I will use a preloaded stone material to cover the selected area. That's it for assigning material and understanding nodes. However, some of you might be asking, where do the colored images come from? I will explain that in a minute. First, I will create material identifiers for the head, body, and base. The material will be left in blank on purpose, and the mesh will be exported in OBJ format to a different software application. With the UV layouts and materials defined, it's time to create the texture maps for the 3D mesh. Now we have imported the base mesh in the Adobe Substance Painter interface. Adobe Substance Painter is a procedural texturing tool widely used in design, film, animation, and video game industries. There is a complete set of tools to add color, lighting effects, and materials for screen visualization. Adobe Substance Painter also possesses an ample library of materials and online assets. In the interface, there is a 3D viewport and the UV map layout. On the top right corner, we can see the name of our previously created materials. This will keep things organized as we work. For this project, I only need the base color texture map, and I will use the power of procedural texturing to add detail to the surface of the 3D objects. The base color texture can be made from scratch by creating a layer and painting on either the 3D viewport or the UV layout. Designers can drag and drop materials from the library as well, and change all the parameters. Modifications can be done to the position of the image, scale, rotation, and displacement of the surface. I have preloaded a stone texture and a wooden texture for this project. The surface of the stone material has some depth and detail in it. This is possible thanks to a displacement map. The displacement map is a black and white image that provides volume to the mesh surface. Color layers can be added to manage the displacement of a mesh. For example, the displacement of the base of the figure can add instability to the body. By adding a mask, I can restrict the displacement at the fit area and improve the contact surface. It's possible to create several adjustments and preview the details before projecting into the mesh. Once the color and details look okay, the base color maps and displacement maps can be exported. Back into the Blender interface, it's time to project the displacement maps on the mesh surfaces to add detail. To do this, the multi-resolution modifier and displace modifier are required. The multi-resolution modifier will subdivide the faces of the mesh to add fine details. The number of subdivisions depends on the detail of the displacement map and the real-life scale of the 3D printed piece. 3 subdivision levels are enough for this project. The displace modifier can move the faces of a 3D object by loading an image or using 3D coordinates. A displacement image can be loaded and the detail projected using the UV layout. Designers can adjust the displacement values and modify and update the displacement map if needed. Once the parameters of the modifiers are set, it's a good practice to create a copy of the mesh and then apply the transformations. When the modifiers are applied to the 3D object, the mesh will contain a large number of faces. Files with too many faces will impact the computer's performance and will take longer to analyze and slice. The final step will be to optimize the file for 3D printing. I will export into components. One will be the body and the other will be the base. Decimating the mesh is done through the decimation modifier. Decimation will process the topology and reduce the number of faces of the mesh. In here, we have both the decimated and non-decimated versions of the head. When decimating, go as low as possible without losing the fine details. The final size of the print will dictate if more or less faces are needed. For this example, I can get away with a lot of decimation. Even if I lose some fine detail, the high definition color of a texture will enhance the appearance of the final print. Our next move will be to export the mesh and inspect it with NetFab. NetFab is a professional 3D printing file preparation software tool. You can inspect a mesh for errors, analyze wall thickness, create cuts for test printing, print layouts, and more. I will import the mesh into the interface by drag and dropping the mesh files. None of the components have errors, however, we will inspect them for educational purposes. First, I will select the body. The mesh must be watertight, with no bad edges, inverted faces, or holes in the mesh. I will open the repair tool and look for errors. Holes and bad edges will show in yellow, inverted faces will show in red. All shells are okay, and we can see the difference in face count of the head versus the body. Now I select the base and do the same. In here we can see the flat area created for the figure to stand. This is a good example of the versatility of texture-based projections. NetFab supports both of our 3D color printers. I will create a new scene with the 3D UJ553 printer. Then I will copy the mesh into the new scene. I will select the body and click in Orient Part. The software will calculate orientations to save time and material. A decimated model will reduce time in automatic calculations. Sometimes the model might be too complex and you will do better rotating the parts manually. Once the calculations are ready, you can choose the most convenient orientation for the print. I left a gap for the base to fit underneath the body and optimize the space and print time. I could send the job like this, but I'm not sure if the color will be correct, so I will create a new printer scene to cut a section of the head and do a test print. It's better to be safe than sorry, so testing is a must if you are developing a new prototype or printing in a specific set of colors. If the print test is successful, chances are that you will have a photorealistic full-color 3D print in your hands very soon. Thank you for joining today and stay tuned for more Mimaki Innovation Days.
All right. So,
Thanks, Jaime. That was great. So I had a couple of questions that I just wanted to throw out there. One is, when you're talking about decimating the faces, is there any kind of a target that you're looking for as far as a number to reduce down to, or a sort of a sweet spot for 3D printing, or is it just dependent on the model itself?
yeah, it's I mean, it really depends on the model. So I mean, just to kind of show here, so I have this model here, which is a sculpture. This one will require a lot of faces, so you want to keep a lot of fine detail. There is fine detail in the skin, in the head. So in this case, you don't want to do too much decimation here. But then you have something like this, which is a very simple. The surfaces are very, very simple. This is completely flat, so you can go as low as you can without losing the edges here. So it really depends on that geometry. Also, the scale, the size, the final size of the model will will determine how much decimation you can get. That's why it's very important to test each part before printing. I mean, if you're not sure, always create a test with different decimation values and try to find the lowest one, so everything can go faster from file inspecting to slicing. Everything goes faster with a decimated model.
So if you're reducing the number of faces, let's say, or facets, whatever, however you want to refer to it, you're still wrapping the entire thing with what potentially is a high resolution texture or color.
Yeah, that's correct. So that's where the advantage of texturing comes into play. As soon as you make a UV layout, the color can be any kind of resolution. I definitely recommend to go never go over 4K in resolution. It's 4096 by 4096 pixels. That will be your starting point. But then after that, you can also reduce the size of the image. So yeah, you liberate a lot of resources as compared to what it's called vertex coloring, vertex painting. Because for vertex painting, you must subdivide your mesh several times just to get the color. So I mean, you're just wasting computer resources and precious time as well. And you cannot decimate. As soon as you decimate, you will be ruining your color.
So as we're talking about resolution for the texture, one of the things that I think is kind of interesting is that you've got the file resolution for the texture itself, but then you have the resolution of the printer. And with the new 2207, 3D UJ 2207 that Mimaki's released recently and is shipping now, the resolution on those print heads are higher. So how do you see that as far as higher resolution on the print head, but it has maybe a little bit thicker in the z-axis versus the 553, where you can get a lower resolution for the thickness, but the resolution of the XY isn't as high as the 2207. What in realistic terms, what does that mean to somebody when they're actually holding prints in their hand?
Yeah, well, I mean, that goes into how much. I guess, I mean, that X and Y resolution, it tends to be overlooked by many people. A lot of people actually focus on the Z-axis resolution. That only defines how smooth is your surface. But the X and Y resolution are very important, especially for people who are looking for accuracy of the machine. I mean, how many details can you get in each print. So this is where, yeah, the 2207 is going to shine. It's going to, I mean, you cut down a little bit your speed but at the same time you're getting really nice and crisp detail on each print. So yeah, I mean it's just a matter of what is the purpose of the prototypes that you want to develop. So on the 2207, you want super high quality, nice definition on the edges, or good accuracy for like the small prototypes. If you have the fittings like this one here. So for example, you want the tightest fit here. So the 2207 is gonna definitely shine in that kind of parts. But now, if you want a bigger part like this one, for example, yeah, the bigger model, the 5x3, is gonna definitely be a better tool to develop this kind of bigger parts.
Excellent. So we have one question in the chat so far. Are the machines supported by Material Magics as well as NetFab?
Well, you can create scenes in Materialize Magics as well. I mean, but you cannot send jobs directly from Magics as compared to NetFab. But you can also try to create a scene and create layouts over there. But yeah, I feel like in that case, NetFab has the full support of our machines, and you can create M3C file, which is the file extension to send the jobs, straight into the printer.
So with NetFab, you can go use the MC or M3C file, go straight to the printer. You can also go to the Mimaki 3D Link software if you need to get estimations on time and ink usage.
Yes.
But so you're saying for Materialized Magic, you have to go straight through the 3D Link software and then out to the printer.
That's right.
Okay, very good. So we've got another question, and I know you have some additional slides that you wanted to show, Jaime. But so maybe while you start to bring those up, I'll read you this other question.
Yeah.
Question is, could you please go over the best workflow for opaque models nested within transparent materials? Also, the best way to deal with both opaque and transparent in the same model.
Well, so in that case, you can create different shell. Let me try to illustrate that real quick in here. Oh, yeah, that one is well. So just kind of before answering that question. So yeah, the first thing, going back to the a quick recap to the video is make sure that to understand what is the purpose of your print. If you have going back into if you have assemblies, if it's just a single piece with nice color but there is no ability or functionality into it, or if it's a complex, this will be considered like a complex piece with internals. So make sure what is the purpose of that print, and also what's going to be the scale, the final size of that print, because you must work in function of that final result. When it comes to working with with encased figures like this one, for example, this one has a clear shell on top of the opaque. So basically, you will export the clear shell in a separate file, and then you can assign that clear in within 3D Link. That's going to be the best way to do it. When you export, make sure that everything is in the same position as in your scene, and in that way you can import and group both files.
So is that you mentioned earlier the term an assembly? Is that what you mean by taking two separate, say STL files or two separate files and printing them as one?
Yes, yeah, that will be an assembly. Obviously, there is fixed assemblies and mobile assemblies. Like this one it will be considered also an assembly. The card that is on the screen is a fully functional RC card, and that one has a lot of parts, so many components, and you have to put them together. We have regular hardware as well, so that's a more complex. So yeah, that's I mean it's kind of broad that concept of talking about an assembly. Yeah.
Okay.
So yeah, that's basically how it goes. I mean, every part was color coded in there, and you can see the internals of the card and a little bit how it works.
All right, very good. I don't see any other questions at the moment. So do you want to go through some more of these the slides that you have?
Yeah. So so we so again, coming back into designing with a purpose, just make sure that everything functions. Do a lot of testing. Testing it's so important, especially when you're kind of new to the part that you're developing. And testing it's very important. Always try to read as much as possible. As well, try to find other resources. Right now, that is the 3D printing community. It has a lot of information out there, so you're not like completely alone when it comes into like try to find the solution for a specific part. Let me go. For some reason, I cannot.
You want to go to the next slide?
Yes, please. Yeah. So, for example, in there, when it comes to optimize, and again, finding the purpose of the print, another advantage of doing assemblies is actually uh, how to maximize your print size. So, in our newer model, the 3D UJ 2207, we have an 8 by 8 by 3 inches print envelope. But that does not mean that I can, come out with a bigger print. So that's kind of the montage for this figure in here. It was divided in 3 different parts. So 2 parts for the seat. Yeah, you can see it there. And also another part for the body. And this is a much, if you put it all together, so it's a much bigger print. Uh, and that's a way to actually maximize the print size. And also, it's going to be very convenient when you need to pack and ship all these parts. So the possibility to break some of the parts is gonna be reduced by separating into components. And if you break a component, you only print the part that you broke, or if you need to redo something. So it's just one print. So that's another bigger advantage to do components. You can always reduce print time as well. So that's a good practice. It's a very common practice for most of the industrial processes. Try to have components, and that is just the convenience and reduce part rejection.
All right, it looks like you have one more slide here.
Yeah. So coming back into testing, so you can see we have 2 different models in here. So basically, I exported that into, in this case, it was NetFab, and I did a small slice cuts, like in areas that I thought it was going to be critical for the color, and just to check, how the color is going to look, if all the features are working. So testing it's very important, and each 3D project is different. So in especially for us, we benchmark parts for so many customers, and we always have different projects. So it's always a we have to come out with new solutions, or all the problems. Every match is different. So that approach is if I'm not sure of what I'm doing, I test first, and then I go back with the final piece.
Excellent. So when you're, Mimaki being traditionally a 2D printing company, and that's obviously your background and my background as well as 2D printing. As you get to this point where you're starting to work with color and 3D printing, there's obviously challenges, just like we have on the 2D side of what you see on the screen versus what you're actually printing out. Is this essentially the same concept? Is that you're getting to know the machine, you're working with a specific profile on the machine, and then you're making some small test prints and adjustments in order to output what you finally want?
Yeah, I think it adds. For people who are experienced into 3D, which is definitely not my case, but it's going to add it's an extra variable for them working with color. Obviously, so you have to start reading about color management, color profiles, input profile, output profile. Don't go too crazy, especially if you're not. If you're only aiming for for I guess a perceptual color. So there is no need to go too crazy with the color accuracy. Yeah, on the other hand, yeah, working color accuracy, using advanced instruments like spectrophotometers, to calibrate a screen, and also to create on a specific set of color in a profile for the machine. Yeah, it's definitely. I mean, it's an advanced solution, but also it makes everything a little bit more. I mean, becomes complicated. So sometimes there is no need to overcomplicate things.
Right.
It's just, yeah. At the end, and this is something that I learned from commercial printing. It's sometimes you will be asked to print on a specific color under certain conditions, and then suddenly you have to rush the job and have a different setting for the machines, and the color is not going to be the same, and it just happens. You have to
Right.
go with production and get that target. So sometimes it's a little bit. I mean, taking care of color it's important, but don't go too crazy with it. Most of the times you have to actually deliver something to the customer, and that's going to be the main
Sure.
the main concern. Yeah, obviously, yes. I mean, quality is important, but it really depends on the project. So every day is just a different. I guess I would call it a different struggle.
So we've got another question on color, which is, does the machine color drift over time and require recalibration, or does the color profile only need to be calibrated once? And I think we would both agree that this is, while it's a 3D printer, it's still an inkjet printer, right? And so inkjet printing, regardless of 2D or 3D, is going to be dependent on a lot on the environment and the environmental conditions, right? So the profile that's made for these machines is made under a specific condition, and as long as that machine stays within that specific condition, you should get consistent color. Consistent color is something that we hear from our customers with this machine, that it's very, very good. However, if you are to take this machine and you have it installed, let's say, near a door, and you're going from summer to winter, and there's the room itself is not in a well maintained for environment, that's really going to affect your color drifting more than anything else. Would you agree with that, Jaime?
Yeah, I think it's well, that's a lot of variables, and again, I think I feel like it's a little bit romanticized when it comes to get accurate color most of the times. So first of all, if you're thinking about accurate color, so you must be measuring all the time, with advanced instruments. You cannot just go ahead and say, oh, just trust your eyes, because the objects under different lighting conditions are gonna look a little bit different, and everybody has a different. I mean, color is very subjective to the human
Sure.
eye. So I feel like
in this case, though, they're asking about color consistency. Do you find? I mean, you've probably run more prints on the Mimaki machines than other than maybe one or two companies. Probably, you're in the top 90% for sure. What have you found for these machines as far as consistency over time from the color?
I mean, it's really good from just a perceptual point of view, right?
Okay.
So yeah, if we go with the instruments, there is always a little bit of color differences. Again, there is variables like temperature. There is also the wear and tear of the print heads. I mean, the print heads are very durable, but that does not mean that the performance is going to be dropping over time. But we're talking about 4 to 5 years. I still have my original CMYK print heads on my demo units. The only heads that I had to change was the support heads in the white heads, which actually makes sense because those are the heads that
so much more.
Yeah.
So one last question, because I think we're kind of at time here, unless I see another one pop up in the list. Going back to the original conversation about color and texture and things like that. With the 3D UJ2207, we would expect that there are going to be more people entering into this full color 3D printing that maybe don't have a lot of design experience with 3D or familiarity with the 3D tools. You showed us Substance, some products from Adobe Substance 3D. You showed us products from Zbrush. You showed us products from Blender. What would you recommend that people kind of focus on if they're really first starting to work with UV maps and texturing?
Yeah, well, I guess it's just read a little bit about the concept. Honestly, when it comes to the tools, it depends on how much do you like the interface of each software. It's just a personal preference. But at the end, it's all the same basics. So if you start developing the modeling skills, it's a must. That part is a must. And obviously, if working with color, texturing is going to be so much better as compared to vertex painting. From there, yeah, it's up to the person. There is different budgets. So for example, Blender is a great alternative if you don't have any money at all. So it's I don't know, it's like the enduro bike of 3D software. Like you can do a lot of things with the same software tool. So it does a little bit of everything. But at the end, as you get more experience, you might find that other software offers you better tools and all of that. Um, Same goes for the specialized software when it comes to 3D printing. So Materialize Magics and Netfab are the most used professional solutions for 3D printing. There's a lot of convenience, a lot of automation. It's easy to analyze, but you can also use open source software if you want to. Obviously, there is more steps to it. So
So while we're talking about that, one last question, and then we'll let people go. So we talked a little bit about Materialized Magics and talked a little bit about NetFab as far as fixing files. Let's just mention very quickly that there is also a Mimaki solution, the 3D Print Prep Pro, which is a newly released cloud-based software. So it's a monthly subscription that people can pay and then upload an unlimited number of files that can be fixed in the cloud. So and please correct me if I'm wrong, Jaime, but things like making sure that things are watertight, making sure that you don't have inverted normals, as you mentioned earlier, thickening parts, thickening walls. I think you've even mentioned that it's really good for people who are getting files off of scanning. So if you're doing, figurine scanning, something like that. How has that been for you? I know you've used it a reasonable amount recently. What's your experience been with the Mimaki 3D Print Prep Pro software?
yeah, I mean, it was a great experience, and specifically for the file that we are looking in the screen, for example, I was able to have a printable file with color in it was about 3 hours, 3 to 4 hours it took to process, and it did all the so the machine was completely watertight and fully it was ready to print, and I took almost 4 hours editing the software. So if you really think about it, I mean, with some files you can cut down print time if you don't really go for a specific. For example, if it's just a solid piece like this one, the software is gonna do wonders for you. I mean, you can just set your part to fix, check the scale, the parameters, and that's it. I mean, you can just keep working with other stuff because you can do all of that in the cloud. So it's good for that. It's good for a beginner as well. I mean, if you have no idea and you still need, you want a small 3D print from Mimaki, so you can actually download a file from, let's say, TurboSquid, from any of the 3D uh, of the 3D resources that are on the internet, you know, and yeah, just have a printable part. Obviously, there are some stuff that is a little bit more advanced, like try to create inserts and all that. So that's gonna be definitely on the designers. And if you want more control, so yeah, you definitely need to do that manually. But in general, the software can create 3D printable parts pretty quick. I mean, it's just
Yeah, if you're able to go from 4 hours of manual work to 3 hours of mostly automation for
yeah.
a low monthly fee, I think that sounds like a fantastic place to start.
Yeah. So I mean, whenever I have the chance, I mean, I will try to do that. But also, I mean, it's good for me to also check manually certain things.
Sure.
So it really depends on the project.
Okay. I don't see any additional questions, so I think at this point we're going to go ahead and end the session. So I want to thank you, Jaime. You did a great job, very informative. This session has been recorded, so once the recordings are done and uploaded, these will be available to view as well. And I think that you will be seeing more videos and tutorials and things from Jaime on 3D printing as we move through 2022. Thank you to everybody. And we look forward to seeing you at the next Mimaki event. Thanks so much.
Thank you.